If the electronic die, there will be no mobile phones. There will be no radio receivers. There will be no TV receivers. There will be no microprocessors, no microcomputers. If the electronics die, then this means that the world as we know it today will go.
But there is a point where you cannot improve anymore. For example...
Now this is why we are here as well. To show that, yes, no way to improve anymore on the scaling down of the MOSFET. Then we have to find other ways.
That means we'll have another technology.
Of course. Well, why I'm here? To introduce you to this new technology. Okay. All what I have said so far is a little bit of history. How it was developed, what the problems we are facing, and to prove that, alas, we cannot do anything more. So we have to change our mind. We have to change our direction. We have to move in another direction, or in other words, we have to find a new technology. So, and this is the heart of the lecture, of course, or the seminar, in fact. It's a new technology. ماشي؟ Any more questions so far? طب ما تشوف كورس خد على عقلي. أنا مش هجلس طبعا. تعال. أنا مش هجلس. أنت أكيد مش هجلس. We agree? يبقى the scientists have done their best to scale down the transistor, the MOSFET طبعا, as much as they can. But they are facing the physical problems. No more scaling down can be done while maintaining the relationships which we know as is. No way. So we have to think in a different way. And this is what is coming soon, inshallah. The carbon nanotubes, the single electron transistors, and the membristors. And we will start with the carbon nanotube. It is the most developed one of them, and it is around us anyway. In a way or another, it's around us, but not, of course, very popular as the MOSFET which we know. The carbon nanotube is based on the idea, and of course, if you go to the people in the chemistry department, they will say, what's new? We know the carbon nanotube since 30 years ago, and they are right. But they don't know it as an electronic device. They don't know it as an amplifier. They don't know it as an oscillator. They know it as a chemical development. But here we are discussing it as an electronic device, which can work as an amplifier, which can work as an oscillator, which can work as a digital gate, digital logic gate. So the carbon nanotube we are talking about may be the same as the one in the chemistry department, but we are talking about it as an electronic device, which can be used for building electronic circuits. You understand what I mean? So it's not new. It definitely is not new. It is known since 30 years ago, but from the chemical point of view, not for us as an electronic device. The carbon nanotube is based on the idea that the material, any material, it behaves in two totally different ways when it is large scale or small scale. For example, the carbon, we know its properties as a large scale carbon, but in nanoscale, it behaves in a totally different way. Some elements, they are in large scale, they are insulators. When we go to the nanoscale, when I say nano, I mean dimensions in terms of nanometer. يعني 10 to the power minus 9 of the meter. يعني something very, very small. يعني maybe the diameter of the hair is around 100 nanometer. Do you understand what I mean? Yeah. So, what I was saying. So the material behave in the nanoscale totally different from their behavior in the larger scale. So the carbon which we know, it is around us of course, will behave totally different in the nanoscale. It will behave as a semiconductor or even as a super metal, a metal of very high conductivity, much better than any metal we know. And it may behave as a semiconductor as well, much better than any semiconductor we know. But this depends on how you develop the carbon nanotube. And we are not going to discuss the details of this. This is physics and chemistry. We are not going to discuss it. But anyway, we assume that we have a well-developed carbon nanotube. It can behave as a semiconductor material. It can behave as a metal. And this was very attractive to scientists because this said that this means that we can build an integrated circuit without using any copper wires. Now, believe me, the bottleneck in designing high-speed computers is not the physical characteristics of the transistors. It is the characteristic of the interconnects. الأسلاك يعني اللي بتوصل الترانزستورز مع بعضها on the chip. It is the characteristic of these interconnects which decide today the maximum speed we can achieve using computers. It is not the physical features of the devices, no, or the transistors, no. It is the characteristics of interconnects. Because these interconnects at very high frequencies, they behave at transmission lines, and these transmission lines have very complicated characteristics. I'm not going to discuss it here, of course, but it has a complicated characteristic which must be taken into consideration by a digital circuit designer. And fortunately, or maybe unfortunately, this is an analog technique. That dealing with the transmission lines is an analog technique. And this is a proof that the people who are thinking in one direction only, analog or digital, they are totally wrong. There is nothing today called analog or digital. Everything is coming together to build one system, analog and digital. Right? Once this carbon nanotube can be used as a semiconductor, it can build the amplifiers and the transistors we want. And it can be used as a metal as well. It can build the interconnects. And as such, we can have one element only on our chip. And this, of course, will make life much easier for the manufacturers and for the scientists. This is how the carbon nanotube looks, but don't forget the diameter of this carbon nanotube is 1.5 nanometer. يعني دي مكبرة كام مليون مرة. مش كده؟ It is just 1.5 nanometer. This is how it looks. And depending on the angle of development of this carbon nanotube, it can work as a very good metallic conductor or a very good semiconductor material. The electrical conductivity of metallic nanotube can exceed that of the best metals. The transconductance and mobility of nanotube can exceed that of the best semiconductor, so it is better in all cases. Nanotube's environment may affect whether it's truly metallic or not, and it's not necessarily. Nanotube diodes are available, nanotubes amplifiers are available, and this is how how a carbon nanotube FET can be developed. What was the problem with the MOSFET? The thickness of the oxide, it cannot be reduced below few nanometers, and the length of the channel. Now, by placing a carbon nanotube between the metallic source and the metallic drain, the drain and the source are now metallic. They are not anymore semiconductors. Between the metallic source and the metallic drain, we add here a carbon nanotube. This is our channel. This will be our channel. And the silicon dioxide will be here, we don't care much about its thickness, and the gate will be here. And under the effect of the gate, we can control the amount of current which will flow between the source and the drain without being so worried about the thickness of the channel. The carbon nanotube is there. There are, of course, voltage, current characteristics, and so on. Everything available for the MOSFET is available also for the carbon nanotube, but I don't want to go to this details. So what happens, they replace the channel by a carbon nanotube. So this is a carbon nanotube. And now all the problems of having a thin oxide and all of this does not exist. Because it is just a carbon nanotube and it is working under the effect of the gate. And the thickness of the carbon nanotube is now as low as 1.5 nanometer. Carbon nanotube find applications in analog as well as in digital, but the very important thing here is some scientists have designed and fabricated a full AM receiver using carbon nanotubes. But this full AM receiver contained resonant antenna, fixed RF amplifier, RF mixers, and AF amplifiers. But the point here is that this was developed by people from different departments, from physics, from materials, from material science and engineering, from electrical and computer engineering, and from chemistry.